Alright, good afternoon everyone. There's one last piece of the puzzle that we needed to add. And this one is sort of it's playing around with the idea of both reaction rates as well as equilibrium. And that's called Le Chatelier's principle. Now, Le Chatelier's principle basically says, if I have a reaction and it's hit equilibrium, it's gotten to that point where the rates remain constant over a period of time. If I add a stress to it, I can get that reaction to shift to reduce that stress or that change. Well, you may be saying, okay, Mr. Baldwin, reactions don't have feelings, they don't get stressed. Well, there are certain things that I can do that will adjust it. The first thing I can do is I can play around with the concentrations. So say I have a reaction that's gone all the way to equilibrium and I add another substance in. Something else that participates in that same reaction. It says that the system will shift away from the added component. So that means if it's on the reactant side, I'm going to form more products. If I add more of the product in, I can force the reaction to go back towards the reacting side. Same thing is going to happen if I remove something. If I remove some of the product, the reaction will shift to make more of the product. This will allow me a situation where I can actually continue moving and making more, say, ammonia or whatever substance I need for my product without having to stop everything and start from scratch. The second thing that we're going to look at is we're going to look at temperature. Now, we know that we said temperature is the only thing that will change the K value. But if I increase the temperature, the reaction will shift towards the side that is endothermic, or towards the side where delta H is positive. If the temperature is decreased, we need to make more energy, so the reaction will adjust and sort of move around in a way that more energy can be produced. That'll keep the particles moving around and so forth. The last thing that we consider is pressure. Now, pressure we considered a little bit last because it's a little bit of an oddball. If we have a system that's at equilibrium and we increase the pressure, say we decrease the volume of the container because we know that they're inversely related. If we do this, that's going to cause more collisions to occur. So, if there are more collisions, the reaction is going to want to be in a situation to minimize that pressure. So, it shifts to the side where there are least number of moles. We might be saying, okay, Baldwin, what do you mean least number of moles? We would literally get a chance to look at the reaction and to count up how many molecules are on each side. If it's the pressure is increased, it shifts to the side with the less moles. If it's decreased, that means we have more space. We want to increase the amount of collisions. It's going to shift to the side of the reaction with more moles. Now, all of this probably sounds extremely weird to you because you're saying, okay, we haven't really dealt with this. Mr. Baldwin, how can we pursue it? We're going to have to do some practice. So we're looking at it more from the conceptual side, okay? So in this one, you're actually very lucky. There are no calculations to worry about at this point. But you want to keep in mind what equilibrium means and how we can sort of manipulate and change it in order to get the results that we want. This is where this video is going to end, and we're going to have to do some more practice with it in class. I look forward to working with you on it, and please write down your questions, and I will answer them in class. Have a lovely day.